AQA, practice paper, set 1, paper 1. Question 1, part A, circle the smallest number. The answer is 2.301. Question 1, part B, circle the largest number. The answer is 7.1, recurring. Question 2, here is a sequence. Circle the expression for the nth term of the sequence. So as we can see, the terms reduce by 5 each time. We subtract 5 to generate the new term, which means that the sequence must be based on minus 5n, which rules out this expression and this expression immediately. So we know that that's the first term, the second term, third term, fourth term and the fifth term, and if we write out negative 5 times 1, we get negative 5 times 2, negative 10, negative 5 times 3, negative 15, and so on and so forth. We need 40, not negative 5, so we have to adjust our expression by adding 45, which can be written as 45 minus 5n, which is this expression here. Question 3. Which of these is not a square number? Circle your answer. So if we look at each of these numbers, 4 multiplied by 10 squared, that of course is 400, which is the same as 20 squared. 4 times 10 to the power of 6 is 4 million, which is 2,000 squared. 9 multiplied by 10 to the 4 is 90,000, which is 900 squared, and the odd one out is 9 multiplied by 10 cubed, which is 9,000, which is not a square number. Question 4. Work out 64.32 divided by 0.12. We're going to write this calculation as a fraction, and we're going to multiply the numerator and the denominator of the calculation by 100. So we create an equivalent fraction, which is 6,432 over 12. Now, because these are equivalent fractions, they are the same value, which means that the answer to this calculation is the same as the answer to the original calculation. We can then calculate 6,432 divided by 12 using short division, or by simplifying this fraction here. 12 divides into 64 5 times, leaving a remainder of 4. 12 divides into 43 3 times, 3 12s are 36, leaving a remainder of 7, and 12 divides into 72 6 times exactly. So the answer is 536. Question 5. The scatter graph shows the number of driving lessons and the number of tests needed to pass by 10 people. Describe the correlation. We can see that this is a strong positive correlation. A line of best fit, which we would draw with a ruler, not freehand, would pass through, and the points are matching the line closely. Part B. Use a line of best fit to estimate the number of tests needed to pass by a person who has 50 lessons. So again, using a ruler, we would draw in a vertical line to meet the graph at 50 lessons. And then again, using a ruler, we go across to the number of tests, and we can see that it's just under 4, perhaps around 3.8. However, the number of tests has to be a whole number, so 3.8 needs to be rounded up to 4. 5 part C. Mira says, I can use the trend to predict the number of driving tests needed to pass for any number of driving lessons. Comment on her statement. Her statement is inaccurate. as she only has information for up to 65 tests. Beyond this, we don't know if the same linear relationship will hold, and we are doing a process known as extrapolation, where we're making a prediction for a value which is outside of the range on which we have information, and this may not be valid. Question 6. Which of 2/5 or 5/8 is closer to a half? If we give all three of these fractions a common denominator, we can compare them carefully. That common denominator for 5, 8 and 2, the lowest common denominator is going to be 40. So we'll rewrite all of these fractions as fractions with a denominator of 40. So 2/5 will become 16/40, 5/8 will become 25/40, and a half will become 20/40. And we can see that 16/40 is closer to 20/40 than 25/40 is, so the answer is 2/5. Question 7. A shape is made from rectangles. 7 part A. On the diagram below, shade an area represented by the expression AD plus CD. Now, A is this length over here, and D is this length over here, so an area represented by AD would be this section here. An area represented by CD would be this section over here, or it could have been this section here as an alternative. 7 part B. On the diagram below, shade the area represented by the expression D multiplied by A plus 2C. Now A is this distance here, this is C, this is C, so that red line here is the distance A plus 2C. Now this is being multiplied by D, which means the area that's relevant is all of this. An alternative way of doing this would be to expand the brackets, and you find AD plus 2CD, which is the same as AD plus CD, and then find each individual area corresponding to these three terms. 7 part C. Write down an expression for the area of the whole shape. Well, write down the area of each of the rectangles, AB, AD, AB, CD, and CD, and then collect like terms. We have two ABs, so that's 2AB. We have two terms which are CD, so 2CD, and a final term which is AD. Question 9. Alan, Ben and Carl ran a 1,000 metre race. The distance time graph shows the race. Who won the race? Give a reason for your answer. If we look at the end of each line, or set of lines, we can see that Ben finishes the race in 4.5 minutes, but Carlos and Alan finished the race in 5 minutes. So Ben completed the distance in a shorter time than the other two runners, so he won the race. The second part of this question asks us to describe the race. There are 4 marks available, and we need to make sure we make 4 clear statements which cover each of the 3 runners. So, Alan, we can see, travels at a constant speed for 3 minutes. He's then stationary for 15 seconds before he travels at a constant speed towards the finish line here. His second constant speed is lower than his original constant speed, so he decreases his speed once he starts moving again. Ben also travels at a constant speed, but it's a lower constant speed than Alan's constant speed, as we can see because the gradient of this graph is less than the gradient of Alan's graph. Ben travels at this constant speed for 2.5 minutes. He then reduces his speed, but still travels at a constant speed for another minute. At this point he's reached 3.5 minutes. Ben then increases his speed as he heads towards the end of the race, finishing in 4.5 minutes. Carl travels at the lowest original speed, which is also constant. He travels at this constant speed for 4 minutes. He then increases his speed, still travelling at a constant speed, for the last minute of his race. 9 Part B, describe the race. To do this, we're going to go back to the diagram of the race. Question 10. 2x plus 3y equals 15.5. X plus y equals 6. We have a pair of simultaneous equations and we have to work out the values of x and y. I'm going to leave equation 1 as it is, 2x plus 3y equals 15.5, and I'm going to multiply equation 2 by 2. This gives me 2x plus 2y equals 12. I now have the same coefficient in front of x, i.e. 2 x's in both equations. I can now subtract the resultant equations, which gives me y equals 3.5, and then I substitute this into one of the original equations. Equation 2 is simpler to find x. So x plus 3.5 equals 6. X is equal to 6 subtract 3.5, which is equal to 2.5. So the answers are x equals 2.5, y equals 3.5. Question 11. 5 integers have a mode of 6, a median of 8, and a mean of 10. So here are the 5 integers. The median is 8, which means we need to fill in this middle number as 8. The mode is 6, so that means these two numbers have to be 6. We're assuming the numbers are in increasing numerical order. Now the mean of the numbers has got to be 10. There are 5 numbers, which means that the total of the numbers has got to be 50 if the mean is going to be 10. 50 divided by 5 is 10. Now we have to find the greatest possible range of the 5 integers, which means we need to make this number here as large as possible. Now, so far, 6 plus 6 plus 8 comes to a total of 20, which means these two numbers here have to come to a total of 30, and this number here, which we've starred, has to be as large as possible, and this number here cannot be lower than 8. It also cannot be equal to 8, because otherwise 8 and 6 are both the mode, and we know that 6 is the mode. So to make this number here as big as possible, this number here has to be as low as possible without dropping below 8, which means that this number here has got to be 9. If the two numbers add together to make 30, that means that this number here is going to be 21. So the greatest possible range of the numbers is 21 subtract 6, which is an answer of 15. Question 12. Write this in the form a bracket bx plus c. If we expand these brackets, we have 14x plus 8 minus 4x minus 24 plus 1. It's subtract 24 because we have negative 4 multiplied by 6. If we collect like terms, 14x minus 4x gives us 10x. 8 minus 24 plus 1 gives us negative 15. And then if we factorise 5 out, we have 5 bracket 2x minus 3, and that is the answer. There may be some confusion as to why it says plus c here when we have minus 3, but effectively what we're doing is 5 bracket 2x plus a negative 3, although we don't need to write that. Part A. Estimate the time it would take to drive from Paris to Marseille when the road is straight and average speed of 100 kilometres per hour. So to do this question, we have to measure the distance between Paris and Marseille in centimetres. Now let's assume that this distance is x centimetres. It will vary slightly from person to person depending on how accurately you've measured this with your ruler and where you've placed the start and end of your ruler on the black dots representing each city. Now we know that the scale is 1 centimetre, represents 80 kilometres. So if our distance is x centimetres, the actual distance will be x multiplied by 80, and this converts it to kilometres. We then need to work out time, so using speed equals distance divided by time, time is equal to distance divided by speed, which is our distance of 80 multiplied by x divided by the speed of 100 kilometres per hour, and our answer needs to be written in the answer space here in terms of hours. So we might have 6.4 hours. The question hasn't asked for hours and minutes in this particular case. 13 part B. Comment on how each assumption affects the accuracy of your estimate. So assumption 1, the road is straight. In reality, the road would not be straight. The road would have twists, turns, bends, and as a result, the actual distance travelled is longer than the distance we have estimated, which means our measurement of time is inaccurate. It's an underestimate. It is too low. The real time would be greater. The second assumption, the average speed of 100 kilometres per hour is likely to be an overestimate, i.e. the actual average speed is likely to be lower than this, meaning that our estimate of the time is likely again to be an underestimate. Question 14. The pilot of an aircraft wants to fly from A through to D. The aircraft flies from A to E off course. The distance BC is 1 mile. Work out the distance DE. This is a similar triangles question. This triangle here, ACB, is similar to the larger triangle AED. The distance we're trying to work out is DE. So we set up DE, is this one here, divided by BC, this one here, is equal to AD, which is the total length of the base of the triangle here, divided by AB. So that's DE divided by 1 is equal to AD, which is 60 plus 150, which is 210 miles, divided by AB, which is 60. This means that DE is equal to 210 divided by 60, which is equal to 3.5 miles. 14 part B. How should the aircraft have turned at sea to fly directly towards D? The answer is between 1 degree and 2 degrees clockwise. Question 15. The shape is rotated 90 degrees clockwise about point A. So to carry out this rotation, take a piece of tracing paper. On your piece of tracing paper, draw over the shape and then press the point of your pencil on the centre of rotation A and then rotate the tracing paper 90 degrees clockwise, i.e. a quarter turn 90 degrees clockwise, and this will give you the new position of the shape as shown in red here. The shape is then enlarged by scale factor -2 with a centre of B. Draw the final shape on the diagram, so scale factor of -2, centre B. So, if we take this point here, it is 1 unit away from B. We multiply that by the scale factor, which essentially is 2, to give us 2 units, but we need to take those 2 units in the opposite direction. So rather than counting in this direction, we count upwards to here. So this point here, which we could call P, is now this point here, P dash. We do the same with this point here. It is 1, 2, 3 units away from B. We double that to make 6 units, but we count in the opposite direction from B. So 1, 2, 3, 4, 5, 6. So that point there becomes this point up here. So if this point was Q, this point here would be Q dash. And we have the new side of our triangle, being careful to draw on the grid lines. Now, the third point here, which we'll call R, is 1 unit down and 3 units to the left of B. So to reverse that, we double those distances to 2 and 6, but we take them in the opposite direction. So rather than counting 2 units down from B, we count 2 units up from B, taking us to this point here, P dash. And then rather than counting 6 units left, we count 6 units right. So 1, 2, 3, 4, 5, 6. And this gives us our enlarged triangle with the correct scale factor. Question 16. Rearrange this formula to make x the subject. Start off by multiplying by x, take 5, which gives us y bracket x subtract 5 equals 4 minus 3x. xy minus 5y equals 4 minus 3x. Now we're trying to make x the subject, so we're going to collect any terms containing x on one side. So add 3x to both sides. xy add 3x minus 5y equals 4. This term does not contain x, so we add 5y to both sides. xy add 3x equals 4 plus 5y. Then factorise out x. So x bracket y plus 3 equals 4 plus 5y. And then divide by y plus 3, which gives x equals 4 plus 5y over y plus 3 as our final answer. And don't forget to write this in the actual answer space. Question 17. The diagram shows a rectangle inside a semicircle. The rectangle has dimensions 16 centimetres by 6 centimetres. Work out the shaded area, give your answer in terms of pi. Now, if this is the centre of the circle, then this distance here is the radius of the circle, which we need to find. We're going to use Pythagoras Theorem. 6 squared plus this distance here, 8 squared, is equal to r squared, which means that r squared equals 100 and r equals 10. So the radius of the circle is 10. So the area of the semicircle is pi multiplied by the radius squared divided by 2, which simplifies to 100 pi over 2, or 50 pi. The area of the rectangle is equal to 6 multiplied by 16, which comes to 96 centimetres squared, which means that the shaded area is the area of the semicircle, subtract the area of the rectangle, so that is a final answer of 50 pi, subtract 96. Question 18. Two straight lines are shown. B is the midpoint of AC, and the ratio of TB to BS is 2 to 3. Work out the coordinates of this point here, T. The first thing we're going to do is work out the coordinates of B, because it's the midpoint of AC. So, if we take 15 and 23, first of all, add them together and halve them, we get 38 over 2, which is 19. That's the x-coordinate of T. If we do the same with the y-coordinates of A and C, so 6 plus 12 divided by 2, that gives us 9. So the coordinates of B are 19 and 9. We're then going to draw in a right angle triangle from B through to S. Now, if the x-coordinate of B is 19 and the x-coordinate of S is 31, then this distance here has got to be a value of 12. 31 subtract 19. This distance here has got to be a value of 6 because the y-coordinate of b is 9 and the y-coordinate of s is 3. Now we know the ratio is 2 to 3, so if we draw a similar triangle here, we can work out the base and the height of this triangle here using the ratio 2 to 3. So if we start with 12, 12 divided by 3 is 4, multiplied by 2 is 8, which makes that distance here 8. And then with 6, 6 divided by 3 is 2, multiplied by 2 is 4. So we're essentially using the ratio 2 to 3, using this ratio with 12 and with 6. So we can see that the matching values are 8 and 4. Now, to then work out the x-coordinates of t, we use these distances. 19 subtract 8 is 11, so the x-coordinate of t must be 11. And 9 add 4 gives us 13, so the y-coordinate of t has got to be 13. Question 19. A cuboid has dimensions x centimetres, and y centimetres. X is increased by 10%, so x multiplied, both the x values multiplied by 1.1. Y is decreased by 20%, which means y multiplies by 0.8. Work out and describe the percentage change in the volume of the cuboid. So, the current volume of the cuboid is x squared y. The new volume will be x multiplied by 1.1 multiplied by x multiplied by 1.1 multiplied by y multiplied by 0.8, as these are the new dimensions, which of course is x squared y, the original volume, if we multiply the x and the y together, multiplied by a multiplier of 1.1 times 1.1 times 0.8. So we have to work out this product, 1.1 multiplied by 1.1 multiplied by 0.8. Now, one possible way of doing this is to work out 11 multiplied by 11 multiplied by 8, or 11 multiplied by 88. We can do this using a quick multiplication technique. And this comes to 968. Now, of course, the calculation we actually want is 1.1 multiplied by 1.1 multiplied by 0.8, which means that this product is actually 0.968, which means x squared y has been multiplied by a multiplier of 0.968, which means that the new volume is 96.8% less than the original volume, which means that there has been a percentage reduction of 100% minus 96.8%, which is a 3.2% reduction. Question 20, circle the value of 9 to the power of minus a half. 9 to the half is the square root of 9, which is 3, and 9 to the negative a half, the negative power creates a reciprocal, so 1/3 is the answer. Question 21, expand and simplify this set of triple brackets. Starting with 2x plus 5 multiplied by 2x minus 5, we find that the product of this is 4x squared minus 10x plus 10x minus 25, which simplifies to 4x squared minus 25. We then have to multiply 4x squared minus 25 by 3x plus 7. If we do this term by term, 4x squared multiplied by 3x will give us 12x cubed. 4x squared multiplied by positive 7 gives us 28x squared. Negative 25 multiplied by 3x gives us negative 75x. And negative 25 multiplied by 7 gives us minus 175. This is the answer. It doesn't simplify. Don't forget to write it in the answer space. Question 22. Write this expression in the form a root 2. Now, the hint here is that we have to rationalise the denominator because the answer does not contain any irrational numbers in the denominator of any type of fraction. So 26 over root 2, we multiply by root 2, we multiply by root 2 in the numerator and denominator, giving us 26 root 2 over 2, which simplifies to 13 root 2. We then do the same with 12 over root 18. Now, we can multiply by root 18 and root 18 here. We could have simplified root 18 as a starting point, or we can do that afterwards. So this gives us 12 root 18 over 18, and we then continue simplifying. So 12 divides by 6 to produce 2, and 18 divides by 6 to produce 3. So we effectively have 2 root 18 over 3. Root 18 has to be simplified to root 9 root 2 all over 3. And because root 9 is 3, those two will simplify, leaving us with 2 root 2 as an answer. We finally have to simplify 2 root 50, which is 2 multiplied by root 25 multiplied by root 2, which is 2 multiplied by 5 multiplied by root 2, which is 10 root 2. This means that the overall expression simplifies down to 13 root 2, subtract 2 root 2, and then add 10 root 2, which simplifies down to a final answer of 21 root 2. So A equals 21. 23 part A. The graph of y equals sine x is shown here. On the grid, sketch the graph of y equals sine x minus 1. Now the negative 1 here represents a vertical translation by 1 unit downwards, i.e. a vector of 0, negative 1, so the whole graph shifts down 1 unit. Question 23, part B. The same graph of y equals sine x is shown. We now need to sketch y equals negative sine x. This is a reflection in the x-axis, which means that our sketch should look like this. 23 part C, on this grid, sketch the graph of y equals tan x. Now, tan x does not exist at x equals 90. It's undefined at x equals 90 and x equals 270. So we draw in these vertical lines, these asymptotes. The graph starts at 0, increases up like that, but never meets that asymptote. The same here. And the same here. We show it increasing or moving towards that asymptote, but never actually meeting it. Question 24. A bag contains n beads. 2 beads are taken from the bag at random. Show the probability that both beads are white is n minus 2 over n. So, if we sketch a tree diagram, the probability that the first bead is black is 1 out of n. If the bag contains n beads and one of them is black, there must be n minus 1 white beads in the bag over a total of n beads. This represents the first bead that's selected. 2 beads are selected, so if we draw the second part of the tree diagram, the beads could be either black or white. However, there was only one black bead in the bag, which means that if we were following this path of the tree diagram, the first bead selected is black, which means there are 0 beads left in the bag that are black, so the probability of selecting a black bead is 0, and the probability of selecting a white bead is 1. On the other path, however, a white bead was selected first, which means there is still 1 black bead remaining in the bag over a total of n-1 beads. There are n-1 beads in the bag because we started with n beads and we've taken 1 out. There are still n-1 beads in the bag if we fill in this probability, but because 1 white bead was removed, there are n take 2. Now the probability that both beads are white, well, we'd have had to follow this path and this path on the tree diagram, which means that probability would be n-1 over n multiplied by n-2 over n minus 1, and of course the n-1 cancels, leaving us with n take 2 over n as our probability. Part B. The probability that both beads are white is greater than 0.9. Work out the least possible value of n. Now the probability of both beads being white is this, n minus 2 over n, and that's greater than 0.9. We've got to solve this inequality. Multiply by n, so n minus 2 is greater than 0.9 n. Add 2, so n is greater than 0.9 n plus 2, and subtract 0.9 n. This gives us 0.1 n is greater than 2, and if we multiply by 10, that gives us n is greater than 20, which means the least possible value of n is 21. Question 25. ABCD is a parallelogram, ABE is a straight line, and AB to BE is 3 to 2, which means that AB is 3/5 of the line AE, and BE is 2/5 of the line AE. BC and ED intersect at F. Part A. Work out ED in terms of A and B, giving your answer in the simplest possible form. Now, the first thing we are going to do is use the fact that AB, which is A, is 3/5 of AE. So effectively, A, you can think of, must equal 3/5. Now, this means to find BE, we need 2/5 of AE. Now, using this relationship, A equals 3/5 of the total AE. Now, to get 1/5 of the total, remember that A equals 3/5 of the total, you could almost draw it out as a diagram. So 1, 2, 3, 4, 5 parts. So AE is the whole thing. A represents 3/5 of this, so 1, 2, 3. So that's what's represented by A. So to get one of these boxes, which is 1/5 of AE, we have to divide A by 3. Now, BE, we know, is 2/5 of AE, so 2 of these little boxes, which is 2A over 3. So BE equals 2A over 3, or 2/3 of A. To then get the vector ED, we have to do EB, the path EB, plus BA plus AD. Now EB is the reverse of BE, so it's negative 2/3 A. BA is the reverse of AB, so it's negative A. And AD is simply positive B. So the answer, if we simplify this part here, is negative 1 2/3 of A plus a B. Or if we wrote this as a top-heavy or improper fraction, that's negative 5/3 A plus B. Deduce EF in terms of A and B. If we look at the diagram again, EF is 2/5 of ED using this ratio we had earlier on. So EF is 2/5 of ED, which is 2/5 of negative 5/3 A plus B. This, of course, is then equal to negative 2/3 A plus 2/5 B. We simplify the fractions when we multiply.